Hello student, let me start the second chapter matrices from the 12th science and commerce. Let A equal to the square matrix 2 1 0 minus 1, which is the 2 by 2 matrix. Now here we can see here there are 2 rows and 2 columns. The horizontal lines are called as the rows and the vertical lines are called as the columns. See, in this matrix there are 2 columns, first column, second column, and there are 2 rows, first row, second row. Therefore its order is nothing but 2 by 2. The first one indicates the number of rows and the second one indicates the number of columns. Similarly, let me take the second matrix B, which is the 3 by 3 matrix. Means in this matrix there are 3 rows and 3 columns. Therefore this is the first row, this is the second row, and this is the third row, and this is the first column, this is the second column, and this is the third column. Therefore this is nothing but the order of 3 by 3 matrix. What is the meaning of a square matrix? A matrix in which number of rows is equals to number of columns. Square matrix means the definition is nothing but number of rows is equals to number of columns, then that matrix is called as a square matrix. You can observe matrix A and matrix B, in which number of rows and number of columns both are equal. Therefore A and B are also square matrices, or you can take these are nothing but the examples for square matrices. Let me see the next one, row transformation. What is the meaning of row transformation? Means we are interchanging the rows in this transformation, and column transformation means in which we are interchanging the columns. We know that row means horizontal lines. Therefore let me see one example. Suppose A equal to the matrix 1 3 2 4. It is nothing but the 2 by 2 matrix. It is the square matrix. Let me apply one transformation here by R1 interchanging to R2. Means R1 is going to interchange with R2 and R2 coming in place of R1. Let me see the next one. A equal to, how it becomes true? Means R1 interchanges to R2 means R1 is going to replace by R2. This is my first row 1 3. It is going to replace by 2 4. Means this is my first row R1 and this is my second row R2. Means in place of R1 we are putting R2 2 4. In place of R2 we are putting R1 1 3, like this. Means we are interchanging rows in this way. Let me see one another example for 3 by 3 matrix. This is my 3 by 3 matrix. Okay, in this there are 3 rows R1, R2 and R3. Okay, the horizontal lines are nothing but the rows. Therefore A equal to 3 7 0 4 2 1 7 minus 4 2. Means this is the 3 by 3 matrix in which 3 rows are present. Now I am going to apply the operation by R2 interchanging to R3. See, the operation is applying on R2 and R3, means the first row remaining as it is, there will be no change in the first row. Therefore we putting 3 7 0 keeping as it is. R2 is going to interchange by R3. Therefore in place of R2 we have to put R3. Means the second row will be 7 minus 4 2. Okay, in place of R3 the second row will become, therefore it becomes 4 2 1. In this way you can interchange any 2 rows or any 2 columns. Let me similarly see the column transformation. Let me see one example. A equal to 4 1 1 2 2 minus 4 0 3 7. This is also a 3 by 3 matrix. In this also there are 3 columns are present. Columns are nothing but the vertical lines C1, C2, C3. C1 means first column, C2 means second column, C3 means third column. Similarly R1 represent first row, R2 represents second row. Now we are applying the operation by C1 interchanging to C2. Means C1 is replaced by C2 and C2 is replaced by C1. So let me apply the operation. A equal to, yes, the C1, the first column is going to interchange by C2. Therefore in place of first column we have to put the second entries 1 2 3 1 2 3, and in place of C2 we have to put the first entries 4 2 0 and the third column remaining as it is. Okay, in this way you can interchange any 2 rows, any 2 columns. Okay, it is sufficient in this video. Let me see the next part in the next video. Thank you.